Welcome to Brain Vision.
So in this video, we're looking at finding a real root of the equation x squared minus the natural logarithm of x minus 12 equal to 0. The using the Regula Falsi method, correct up to 3 decimal places. Now, it says that if f of x is switching sign between the interval a comma b, it has a root, well, at least one real root. The initial guess for this problem could be 3 comma 4. Obviously, you can try guessing 1, 2, 3, 4. You will end up seeing that the function f of x in this case, which is x squared minus the natural logarithm, I've written it in ln form, ln of x minus 12 equal to 0. So if you actually substituted the values of 3 and 4, you would see that the function f of x switches sign between f of 3 and f of 4. As you can see, the f of 3 is negative, f of 4 is positive. Therefore, it means that there is a root between 3 and 4, at least one real root between 3 and 4. Therefore, the Regula Falsi method can be applied with these intervals 3 and 4. So it says that the Regula Falsi method, the formula for Regula Falsi method is x2 equals to x naught minus f of x naught multiplied by x1 minus x naught divided by f of x1 minus f of x naught, which would in this case mean x0 x naught is 3, x1 would be 4, rather 0 x naught is 3 and x1 is 4. So therefore, if you applied this formula for finding x2, you would find that x2 equals to 3.6106. Similarly, using x2 value, so if you substitute the value of x2 in the function, you would see that this value is negative. Therefore, it means that the interval is shrinking between x2 and x4, where x2 and f of x equal to 4, which means it's the root is between 3.6106 and 4, because f of 4 is positive. Therefore, applying the same theory as before, we would see that the next value is 3.6443. And then if you substitute it again, you would see that for this value, f of 3.6443 would be negative. Therefore, the root is between 3.6443 and 4. Finally, you would see that with respect to x4, you would see that the value of x4 at the third iteration is 3.646. If you take the difference between the x4 and x3, you would find that the decimals are approximately up to 3 decimal places in terms of the difference. Therefore, you can say that the root is x4 is the final answer, which is 3.646 within 3 decimal places. So that is basically the conclusion of this problem, and this is the working summary of the problem. So that's the Regula Falsi method, initialization in terms of how the function switch is signed, the equation for the Regula Falsi, first iteration, second iteration, third iteration, and the root within the decimal place up to 3 decimal places, considering that the difference is negligible between x3 and x4.